Welcome to Mind Decoded, where we explore the psychology behind human behavior. Let's decode today's topic. You're stressed. Everyone's stressed. It feels normal, but neuroscientist Robert Sapolsky's research shows that chronic stress literally shrinks your hippocampus, enlarges your amygdala, and weakens connections in your prefrontal cortex. This isn't metaphorical damage, this is physical, measurable brain changes. And if stress continues long enough, some of these changes become permanent. What you dismiss as just stress is restructuring your brain in ways that make you more anxious, less rational, and worse at learning. Here's what happens in your brain when you're stressed. Your hypothalamus activates your sympathetic nervous system and triggers the release of stress hormones, cortisol and adrenaline. In the short term, this is helpful. Cortisol increases glucose availability for quick energy. Adrenaline increases heart rate and blood pressure to deliver that energy to your muscles. This is the stress response working as designed. You face a threat. Your body mobilizes resources. You handle the threat. The stress response turns off. But chronic stress means the response never turns off. Before we begin, a quick disclaimer. This content is for educational and informational purposes only and should not be considered medical, psychological, or mental health advice. If you're experiencing mental health concerns, please consult with a qualified mental health professional. Chronic stress keeps cortisol elevated continuously. This is where the damage begins. Neuroscientist Robert Sapolsky spent decades studying stress and found that sustained high cortisol is neurotoxic. It damages and kills neurons, particularly in the hippocampus. The hippocampus is responsible for memory formation and learning. High cortisol literally shrinks the hippocampus. Brain imaging studies show that people with chronic stress have smaller hippocampal volume than people without chronic stress. This isn't speculation, it's measurable structural damage. The hippocampus shrinkage explains why stress destroys your memory. You can't remember where you put your keys. You forget what you walked into a room to get. You struggle to recall information you know you learned. This isn't normal forgetting. This is stress-induced memory impairment. When your hippocampus shrinks, it can't form new memories effectively. The information comes in, but it doesn't consolidate into long-term storage. Psychologist Sonia Lupien's research shows that people under chronic stress perform significantly worse on memory tests than people with normal stress levels. Stress also enlarges your amygdala. This is the brain region that processes fear and threat. When you're chronically stressed, your amygdala becomes more sensitive and more reactive. Brain imaging studies by neuroscientist Ahmad Hariri show that chronic stress increases amygdala volume. A larger, more reactive amygdala means you perceive threats where none exist. Neutral faces look threatening. Ambiguous situations feel dangerous. Your threat detection system is hyperactive. You're constantly scanning for danger. This creates more stress, which enlarges the amygdala further. It's a vicious cycle. The enlarged amygdala explains why stress makes you anxious. Your brain is processing normal life through an oversensitive threat detector. Everything feels more threatening than it actually is. Someone doesn't respond to your text immediately. Your amygdala interprets this as rejection or anger. Your boss wants to talk to you. Your amygdala interprets this as impending criticism or firing. These aren't rational assessments. These are your enlarged, hyperreactive amygdala generating false alarms. And each false alarm triggers the stress response, releasing more cortisol, further damaging your hippocampus and enlarging your amygdala. Stress weakens your prefrontal cortex. This is the brain region responsible for rational thinking, planning, impulse control, and emotional regulation. Chronic stress reduces activity in the prefrontal cortex. Psychologist Amy Arnstein's research shows that even moderate stress impairs prefrontal function. You make worse decisions. You have less self-control. You can't regulate your emotions as effectively. This is why stressed people snap at loved ones, eat junk food, skip exercise, and make impulsive choices. Their prefrontal cortex, the rational brake on behavior, isn't working properly. The relationship between prefrontal cortex and amygdala is crucial. Normally, your prefrontal cortex regulates your amygdala. When your amygdala signals threat, your prefrontal cortex evaluates whether the threat is real and sends calming signals if it's not. But chronic stress weakens the connection between these regions. Neuroimaging studies show reduced functional connectivity between prefrontal cortex and amygdala in chronically stressed individuals. Your rational brain can't calm your emotional brain effectively. The amygdala runs unchecked. You feel anxious, reactive, out of control. Because neurologically, your emotional regulation system is compromised. Stress impairs neuroplasticity. Neuroplasticity is your brain's ability to form new neural connections and learn new things. Chronic stress reduces brain-derived neurotrophic factor, or BDNF. This is a protein that supports the growth and survival of neurons. Neuroscientist Meaney found that low BDNF levels mean your brain can't adapt and learn as effectively. You have trouble learning new skills. You struggle to break old patterns. Your thinking becomes rigid. This explains why stressed people feel stuck. Their brain literally has reduced capacity for change. Sleep deprivation amplifies all of these effects. Psychologist Matthew Walker's research shows that stress disrupts sleep, and poor sleep increases stress. It's bidirectional. Stress makes it hard to fall asleep. You lie awake worrying. When you do sleep, stress hormones fragment your sleep. You wake frequently. Your sleep is lighter and less restorative. Poor sleep means your brain doesn't get the recovery time it needs. The hippocampal damage continues. The amygdala stays enlarged. The prefrontal cortex stays impaired. Sleep is when your brain clears metabolic waste, consolidates memories, and repairs damage. Without adequate sleep, the stress damage accumulates faster than your brain can repair it. The inflammatory response connects stress to physical disease. Chronic stress triggers chronic inflammation. Psychologist Janice Kiecolt-Glaser's research shows that stressed individuals have higher levels of inflammatory markers in their blood. Inflammation affects the brain. It impairs the blood-brain barrier. It activates microglia, the brain's immune cells. Activated microglia release inflammatory chemicals that damage neurons. This inflammation contributes to depression, anxiety, and cognitive decline. Stress isn't just psychological. It's creating physical inflammation that damages your brain. Here's what's particularly concerning. Some of this damage can become permanent. Neuroscientist Bruce McEwen found that if stress continues for years, the brain changes may not fully reverse even after stress decreases. The hippocampus may partially recover if stress stops, but it may never return to its original size. The amygdala may stay enlarged. The prefrontal connections may stay weakened. This is why chronic stress in childhood has lasting effects. The developing brain is particularly vulnerable. Stress during critical developmental periods can permanently alter brain structure. The good news is that some interventions can reverse or prevent stress-induced brain damage. Exercise is one of the most effective. Neuroscientist Henriette Van Praagh found that aerobic exercise increases BDNF production. This promotes neurogenesis, the growth of new neurons, particularly in the hippocampus. Exercise also reduces inflammation and improves sleep. Psychologist Michael Otto's research shows that exercise is as effective as medication for mild to moderate depression and anxiety. It's directly counteracting the brain changes that stress creates. Mindfulness meditation protects against stress damage. Neuroscientist Sarah Lazar found that regular meditation increases gray matter density in the hippocampus and prefrontal cortex. It also reduces amygdala size. Brain imaging studies show that people who meditate regularly have more resilient brains. They show less hippocampal shrinkage in response to stress. Their amygdalas don't enlarge as much. Their prefrontal cortex maintains better function under stress. Meditation isn't just relaxation, it's literally protecting your brain structure from stress damage. Social connection acts as a buffer. Psychologist Shelley Taylor's research on Tend and Befriend shows that social support reduces the physiological stress response. When you have strong social connections, stressful events trigger less cortisol release. Lower cortisol means less hippocampal damage, less amygdala enlargement, better prefrontal function. Loneliness, conversely, amplifies stress damage. Lonely individuals show more stress-related brain changes than socially connected individuals experiencing the same stressors. Your brain health is affected by your social environment. Sleep must be protected. Psychologist Matthew Walker emphasizes that sleep is non-negotiable for brain health. 7 to 9 hours per night. Consistent sleep schedule. Dark, cool room. No screens before bed. When sleep is adequate, your brain can partially repair stress damage. Hippocampal neurons regenerate. Inflammatory markers decrease. BDNF production increases. Sleep is when your brain recovers. Without it, stress damage is irreversible. Understanding what stress does to your brain changes how you prioritize stress management. This isn't about feeling better. This is about preventing measurable, physical brain damage. Your hippocampus shrinking means your memory worsening. Your amygdala enlarging means your anxiety increasing. Your prefrontal cortex weakening means your self-control failing. These aren't minor inconveniences. These are structural changes that affect how you think, feel, and function. Stress management isn't optional self-care. It's brain protection. And that's how the mind works. If this helped you understand yourself better, subscribe for weekly psychology insights. Thanks for watching.